Hello and welcome. I have a treat for you today as I will be teaching you a little something about normal force and friction. Have you ever pondered aloud during an hour of meditation? Why doesn't a book fall when it is gently placed on a bookshelf? You may be thinking, well, isn't it obvious? The bookshelf is holding it up. And I won't lie to you, you are actually correct. You see, what the normal force is a force that prevents things from falling. Gravity's arch enemy, if you will. As you can see, this little girl is not too excited that gravity is forcing her to fall, trapped in an endless vortex for all eternity. That is, until someone stops her. But that is a subject of its own. This little boy, however, is happy as a clam. They both weigh the same, they both have gravity acting on them, they both ate toast for lunch, but the little girl is clearly falling while the boy is not. It's all in the forces. The little girl has one force on her, Fg, which is the force of gravity. However, the little boy has two, force of gravity, Fg, and Fn, the normal force. You see, the normal force has the same magnitude as the force of gravity, but in the opposite direction, so it makes its F net equal 0, and therefore no acceleration, and therefore a happy boy. Now let's take a look at an average 1975 Victorian mansion in the sunny state of Florida. The book over there is held up by the normal force given off by the shelf. The shelf is held up by the normal force of the house, and the house is held up by the normal force of the earth. For you see, without normal force, everything that we know and everything that we love would be constantly accelerating down without even a floor to stand on. As stated before, the normal force acts opposite to that of gravity. However, that is only true when the surface is parallel to the earth. The normal force will always act perpendicular to the surface. That is why, when the surface is parallel to the earth and no other forces are being acted upon the object, Fg will always equal Fn. When the surface is not parallel and no other forces are acting upon the object, Fn will be equal to the perpendicular force of gravity. Little Billy here is having the time of his life, and it is all thanks to the normal force. You can see that the surface is not parallel, so that means that the normal force is equal to the Fg perpendicular, which allows Billy to slide down the hill. It also keeps Billy relatively safe, as it does not allow him to fall straight down in a free fall. Even Brian J. McAdams here appreciates the normal force. You see, not only is the normal force keeping him at its current level, it also prevents the tiger from falling on top of said Brian, and perhaps causing him to suffer a furry demise. In summary, the normal force will always act perpendicular to the surface. It prevents objects from falling off into all eternity, and it will also be equal to the Fg when there are no other applied forces in the y direction, and when it is also on a plain flat surface. Ooh. Have you ever tried to do a belly down slide on a plain concrete road? If so, you obviously know that you won't be trying that again. Now, you are probably asking yourself, why does the world hate me? And to that I say, it isn't the world that hates you, it's friction. The best way to show friction is with an example. Look at little Jeffrey here pushing his box of toys. Notice that when Jeffy pushes his box, it doesn't continue on forever. In fact, it only moves when he is applying force to it. This is because of a little thing called friction, and it is quite terrific. It prevents little Jeffy from losing his toys, as the box will not travel on for all eternity in the X direction. Just look at that smile. Have you ever even thought about why we are able to slide on ice but not on pavement? Well, let us use Simon the Pussycat as an example. When Simon is on the ice, he is able to slide to his heart's content. However, friction prevents him from sliding for all eternity. You heard it all here, folks. Real ice is not frictionless, and I don't want anyone to say otherwise. Back to the subject in hand, though, one can see that the force of friction on Simon the Pussycat is fairly low. Now let's take a look at Simon on some nice hot pavement. As one can see, Simon cannot slide very well at all, and the reason is that they have very different coefficients of friction. The lower the coefficient, the less friction that is felt by the object. Therefore, the more the object can slide, like our friend Simon the cat here. This brings up another frictional subject, kinetic and static friction. Kinetic friction is the friction that is applied onto a moving object. Kinematics, see the difference? Static friction is the friction that is applied to a stationary object that is trying to move, such as a loaf of bread on a slanted hill. The gravity is trying to bring the bread down to the village people, however it does not apply a great enough force to overcome the static friction. Therefore, no bread for the people. When you think of a static character in a play who does not change. Static and static. Isn't that cool? In summary, the force that is opposite of the applied force is called friction. Friction can also have a variety of coefficients that affect its magnitude. And there are also two different types of friction: kinetic, which is moving, and static, which is staying still. I want to thank you very much for listening and hope you have a great day.